All right, good morning, geometry guys. Coming at you from third period where people forgot how to act in public again. Don't forget to hit like, subscribe with the bell. All right, so we're studying circles. This is a roundabout lesson, okay? So circles are named by the point in the center, okay? For instance, this right here is in the center. It's circle P, not OP, circle P. All right. Diameters, again, some of these two right here, diameters and radius, you should already know, but if I were to put a lot of faith in stuff you should already know, I would be disappointed. All right, so BC is the diameter. It goes through the center. PA is the radius. It goes from the center to the edge. And then we have angle CPA, which is this right here. It's called a central angle because it's formed at the center. Okay, now starting slow, kind of going on through this. Somebody was telling me yesterday, they're like, why is there vocabulary in math? I'm like, there's always been vocabulary in math. So, all right. All right. So, all right. In a word problem, 9 times out of 10, it has too many words. This we could care less about. All right. We need to know to change percent to a decimal, multiply by 360. This is when we're finding central angles, and we're looking for stuff with this little pie pieces. Hang on a second. All right. So, finding central angle, you're going to change percentage to a decimal and multiply it by 360. All right. So, calculate the central angle for work. All right, so this little slice right here. Well, 20% as a decimal, you move the decimal place over 2 places to the left. So when you multiply 0.2 times 360, you get 72 degrees. All right. Sleep, which is this one right here, 0.31 times 360. This is 1.6 degrees. All right. All right. So, now, hang on just a second. This has too much stuff right here. We're going to fill this in. All right. Right now, you only need to worry about the stuff not covered in the pink box. Okay? All right. So, arcs are measured in degrees like angles. Please quit throwing stuff because y'all throw it all the time and y'all never pick it up. No, he doesn't want it. That's why he dodged. Okay? An arc measures equals its central angle measure. An arc is part of a circle. Okay? Basically, if you were to think about it this way, if you had a pizza that was cut in the triangles, okay, an arc is the crust right here. Okay? So, a semicircle is exactly half of the circle. Alright, so this semicircle, we're going to say is TRS. Alright, and then we have to put an arc like that, because we name pieces of a circle with the arcs and stuff like that. Okay? the measure of any semicircle. Okay, think about it. If a whole circle is 360, what's half of 360? Okay, 180 degrees. Okay. Now, so a minor arc, okay? Minor arc would be like that one piece of the pizza that's cut. All right. So there's name a minor arc. All right. So minor arc would be like RS. Okay. You could also said TR. Okay. And this is RS and this is TR. Okay. All right. And if we were asking what was the measure for the minor arc of TR or RT, that we would have said that it is the same as this angle right here. All right. And then lastly, for this slide, a major arc, okay, is larger than half the circle. Okay. So if we were to look like this right here, going this way, TSR. All right. It's basically going to be, 360 minus whatever. All right. All right. You need to write this down on your paper. I'm actually on a pause, so I'm not going to sit here and try to record the whole time because that's ridiculous. So, the question was asked during the pause about major arcs and semicircles. Let's look at this. Major arcs, okay, ADB. It matters which way it goes. Okay, so basically ADB is this whole thing right here, which is larger than a semicircle. Okay, ABC, again, the way it's listed, it matters. Okay, now if we were talking about semicircles, okay, ABD is that, where it's only half of it. Okay. Does that make a little bit more better sense? It may need to marinate a little bit. May a little sizzle, a little air fry. All right. So, arc addition. Very similar to angle addition. Okay. Just keep on adding stuff together. For instance, let's change that. Minor arc BC. This right here. Well, this is 32 degrees. BD would be 32 plus 58, which is 90 degrees. All right. ABC. ABC. This is half of the circle. It is a semicircle. So that would be 180 degrees. All right. Minor arc AB. Well, let's think about it. If this is 180 degrees from here, AB would be 180 minus 32, which would be 148 degrees. All right, so, this is 148. So we could find this right here. What's left? Just be 360 minus 148 plus 32 plus 58. Okay. Alright, just put it down right there. Alright. So 360 minus 148 plus 90. Alright, so this would be 120. Nope. This is 122. Yep. Oh, sorry. Too much. Sorry. A little distracted. Sorry, one person came in and everybody just decided it was free time. So it messed up my train of thought. This little part is 122. What we're trying to find next is different color. Is ADB, which is this to this, which is 122 plus 90, which would be 212. Okay. All right. So, getting towards the last part. Circumference is the distance around the circle. Basically, circumference is perimeter for circles. Is there something else going on? Some of y'all choose to sit beside people that y'all know drive you crazy, and I don't understand that. Alright. So, when we're going to use pi, we're going to use it, we're not going to type in 3.14, we're just going to leave it as pi. Alright. So the diameter of a wheel is 22. What's the circumference? Well, we're going to say pi times 22, which is 22 pi. That's what we're just going to leave it as. Okay? It's too easy. How far does a bicycle travel in one? Okay. Well, guess what? That is the same answer. That's like if you have the tire laid out all the way straight. How many revolutions will it take to do 100 feet? Well, 100 divided by 22. Well, this is like 50 over 11 pi. And we're just going to leave it like that. Okay? For right now. I'll try to worry about if we have decimals or whatever. Stuff later. I would prefer to not have decimals. And pi, it just adds to confusion. And all right, are we good with example 4? All right. The length of an arc is a fraction of the circumference. So, measure of AB, well, that's this, which would be 60 over 360 times, all right, we need the diameter. The radius is 12. If the radius is 12, what's the diameter? What's the other side all the way over? If the radius is 12, 24. Wow. Okay. So times 24. All right. This ends up giving us 4 pi. I just do the numbers and then put pi in later. Okay. Now, on this one here, if this is 60, all this has to be 300. So 300 with 360 times 24. All right, this gives us 20 pi. All right. Reason why, let's see, the total circumference on this would be 24 pi. This is our total circumference. It's a fraction of it. Well, if this is a fourth of it, or 4, the rest of it has to be 20. All right. And that's it for today.